I'm going to look at the inverse of the cosine function. This is a graph of y equals cosine x, and you may remember that in order for a function to have an inverse, it has to be 1 to 1, which means it has to pass the horizontal line test, which means a horizontal line can only go through the graph one time. And there's a horizontal line, that horizontal line and many others like it are going to go through that graph infinitely many times, so the cosine function is not 1 to 1. What we'll need to do then is limit the domain of the cosine function to a section on which it is 1 to 1, so we can talk about an inverse of the cosine function just on that little section. In a perfect world, we could do this the same way we did it for the sine function. If I start at x equals negative a half, or that's not negative a half, negative pi over 2 to plus pi over 2, that worked for the sine function. The sine function was 1 to 1 on that section, and that was fine. The cosine function, still not 1 to 1. So I'm going to have to look for a different way to limit the domain of the cosine function, because using the same one we did for the sine function doesn't work. The standard way to do this is I'm going to start instead at 0, at this maximum, and go to the next minimum, which happens at pi, and look at that little section. On that little section of the cosine function, it is 1 to 1, does pass the horizontal line test, which means I can talk about an inverse. So I'm going to look at the function y equals cosine x on just the domain from 0 to pi, not the whole thing, but just that little section. We'll notice that the range goes from negative 1 to 1. Y values go from negative 1 to 1, and I hit each of those y values exactly once on that little section of the cosine graph. Then what does the inverse cosine look like? I'm going to write y equals, I'm going to read that, inverse cosine x. Or we could say arc cosine x. Those are completely interchangeable. They mean exactly the same thing. And we can pick your favorite, use either one. You may remember also from your past that the domain of the original function is the range of its inverse, and the range of the original function is the domain of its inverse. So that tells me the domain of the inverse cosine function is the range of the cosine function, which is negative 1 to 1. The range is 0 to pi. Let's look at using this. Suppose I want to evaluate the inverse cosine or the arc cosine of 1/2. This means I'm looking for the angle whose cosine value is 1/2 that falls into the right range. The range for the inverse cosine function is 0 to pi, so that's quadrants 1 and 2 only. I want the inverse cosine of positive 1/2. The inverse cosine cosine values are positive in quadrant 1, so no conflict here. I'm looking for the angle in quadrant 1 that has a cosine value of 1/2, and there is only one. That happens at pi over 3. Cosine of pi over 3 is 1/2, so the inverse cosine of 1/2 is pi over 3. Suppose I want to evaluate the inverse cosine of negative root 2 over 2. The inverse cosine of negative root 2 over 2. So I'm looking for the angle that's in the correct range, quadrant 1 or quadrant 2, that has a cosine value of negative root 2 over 2. For the inverse cosine, we really can just keep looking at the unit circle. The first place that happens, the place in quadrant 2 that happens, is at 3 pi over 4. Suppose I want to evaluate the inverse cosine of 2. If you stick this in your calculator, it will return error. And in fact, this is something that is undefined. It is not undefined because my calculator gave me an error. This is undefined. This is not a range problem. This is a domain problem. The value 2 is not in the domain of the inverse cosine function. For the inverse cosine function, I can only input values from -1 to 1. Those are the only ones that make sense. So if I try to evaluate the inverse cosine of 2, it's not defined outside of the domain, so we're going to call that undefined.